For the folks that are just tuning in from the playback on YouTube, I'm going to be starting in a few minutes here. I'll put a link to the timestamp of when I actually get into the content. I'll put that down in the comment section below. But today we're going to be talking about Docker containerization using Kubernetes. Just going to give folks a few more minutes to join, since I just kind of started it abruptly. But for those of you that just joined, we're going to be talking about, so yesterday I did a session on Docker. That was really fun, learned a lot about that. Today we're going to be talking about how to actually deploy Docker. So I found this cool video on orchestration using Kubernetes, and we're going to try to deploy a NodeJS app using Kubernetes. So that's the plan. So we're going to watch this video here. I don't know if we're going to watch the whole thing, but he does like a demo thing that's pretty cool. So I'm probably going to follow along with him when we get to that point. Just going to grab some water. You could. Okay, let's get started. So, like I said, yesterday we did a session on Docker, learned basics, how to launch containers, how basic stuff works. Oh, I just want to move this over, by the way. And then, so let's go over my notes from yesterday, because we learned a lot. So we had Docker daemon, REST API to interact with it, CLI interacts with that. You can connect to the daemon from your local, or the daemon could be somewhere else. Dockerd refers to the daemon, and Docker refers to the API. So then we had images, which are basically a blueprint for what you want to launch. And then they're based off of other images, and it's kind of like a parent-child relationship between the images. Then you can create layers, which kind of are the descendants. So there's multiple layers in one image, and the number of layers is determined by the kind of relationship between this image and all the parents above it. What else? Containers are runnable instances. This was just some command that I had. And then we had services. So if the images are the blueprint and the containers are the means to deploy those blueprints, locally at least, then the services are your means for scale. And then it seemed like you can combine multiple different ones into a swarm, which is a grouping of containers. And it's orchestrated by a single daemon, which I thought was a little bit interesting. What else? So the dependencies, your application config, including your environment variables, everything gets bundled into that image, and you specify your memory, your CPU, your I/O, your disk stuff. I believe it's part of your run command, if I recall. Okay, so this is just some of the syntax from the basic Docker file that you're going to be using. One second here. And what else do we have? So yeah, there's a Docker ignore file similar to git ignore. It tells it to ignore certain files that you don't care about. So Docker run, yes, you can contain or specify a ton of things. And these are just some commands I was running through. So ps-a shows you none. Running attached images ps shows the running images. Rm lets you get rid of them. And if you use this fancy command here, this is mapping your local port 80 to your Docker port 80, and you're giving it the name hello for the instance, or else it'll specify just a random name. And then you're using it off the hello world image. And then, here's the specification here. And this was some command that someone from the chat gave me yesterday, which was very useful, which is to get rid of all your non-running images. So after you do docker ps-a, you can see your non-running images. If you want to get rid of all those, because sometimes it could be quite a list on your console, you can do it that way. Docker stop to stop it, log/f to see the logs. So there's Docker Hub for private images, and it's kind of like source repository. What else? Oh, compose, that's right. So compose is when you want to have like multiple containers working together as part of a specification. At least that's the way I understood it. So you specify YAML files that define the run specification, can be one or more services. One thing that wasn't clear to me at the time was whether or not if you specify multiple different services here, is it one container or multiple? I'll probably figure that out shortly. And then what else? So Docker compose up. So this is, it'll read off your compose file as opposed to just your Docker file if you just do Docker start. Up means run, but all services in the compose. Okay. Then I had some open questions, which I think I answered. Where do we specify the resources? That happens in the run command. Branches of images, and that's done by tagging. So that's where we left off yesterday. And this is the video that I watched yesterday, by the way. And if you check this video, if you're interested in these notes or you want these notes, I put them in the description section of this video and my previous live stream. So you can go and check that out if you want this. I'm also going to be providing the notes that I take today on deploying a Node.js container to Kubernetes. So stay tuned for that. That'll be in the comment section as well. So we're going to follow a similar process as we did yesterday. And the agenda is going to be, I'm going to watch this quick video. It's 40 minutes, but I'm going to speed it up a little bit and probably skip over some bits. This guy does some cool things where he talks about like deployment solutions. So as you can see here, there's a bunch of them. And then he runs through an example of how to set up your Node.js app and then deploy it to Kubernetes. I think he has two things as part of the service file. I can't remember what was the other thing. It could have been Node.js plus Mongo or Node.js plus Express. I can't remember, but we'll see. But that's the agenda today. So that's what we're going to be doing. Hopefully it'll be under an hour, but we'll just see how long it takes. And if you have any questions, feel free to add anything you want to say. Let me know. I read the chat once every few minutes. So, okay, so here we go. Let's see.
So say we have a microservices architecture and we've containerized our applications. How do we run it? This is where the container orchestrator comes in. I'm going to be talking about Kubernetes just because that's what I have experience with. But on the right, you can see all of the different types of container orchestrators that are out there. Azure has their own. Amazon has container service. Marathon is another one. Docker Swarm. Google Container Engine actually runs like Kubernetes in the background. It abstracts it away from you, but it is a container engine. Or you can just run Kubernetes as I'm going to be demonstrating today. So container orchestrators, Kubernetes.
I'm actually going to slow this guy down. He talks pretty quick.
Kubernetes specifically, essentially take a declared state of how you'd like to configure your microservices, your containers, and it makes it happen. And what's really cool is it makes it happen across computers. So in the cloud, let's say I'm running, in Amazon. Or I'm running in Azure or something like that. I, boot up a couple of, compute instances, and I want to run my applications on them. I could individually go, SSH into each one, clone my application, build it, run it. Oh no, it crashed. I have to go back in. There's a lot of different moving parts in it. So hopefully this helps.
Hold on. So we got a node, which is a kubelet or kubelet. So it communicates with the master and you run pods, okay? Pod runs more than one container that exists on a node, okay? Service handles requests, usually a load balancer deploy. Okay, so they have a bunch of different levers or different pieces here of this puzzle. Let me just get the names down. I'll probably fill in the blanks later. So they have a node, a pod, a service, and a deployment. I just want to get like one-liners of each thing. So what does this thing do? Kubelet, can't type today, runs pods and talks to master. The pod, runs 1+ containers, exists on node. Service handles requests using load balancer. And deployment, that just seems like a template file. And Kubernetes kind of orchestrates how everything gets wired together after that. So you say, I want this, and then it kind of makes it happen. Okay?
Figure some of that out. So essentially a node is an instance of a computer. It's running Kubernetes. So kubelet is the the application that is running that communicates with the master node, and a node runs pods. A pod is a definition, and it contains one or more containers. You could have one container, you could have 5 containers running on this pod. So if I run a pod, I'm running however many containers inside it that are declared. And pods, again, are run on nodes. A service handles requests either coming from inside the Kubernetes cluster from one node to another, or from outside the cluster, say public request to our master node that wants to hit a specific service, microservice. So the service tends to be a load balancer. There's a couple different types that you can declare, but the service is essentially a definition of how requests should be routed and handled within the cluster. A deployment, as I said, defines desired state. Kubernetes does the rest for you. So I say, I want 3 copies of this specific container. I want them XYZ, and Kubernetes just does it. So this is kind of how Kubernetes looks, a visualization of it. So you have your master that has replication controllers. Replication controllers essentially handle, making sure that there are, if I say I want 3 copies of a pod, the replication controller ensures that there are 3 copies of that pod.
So that's kind of cool. So replication controller. This seems like it's the orchestrator for determining like pod state. At least it seems like that. So how do you put this in words that make sense that I'll remember later? Manages, I guess, deployment state. I think it ensures health, something like that. Let's keep on going. I may have to correct that.
And it also contains like a history of how I change deployments. So if initially I say I want 5 copies, and then that's not enough, and I say I want 10, I could revert that and go back to 5. Or maybe I have version 1 running, and then I push out version 2, and something breaks. Oh no, I need to revert. I can quickly revert that to the past replication controller. It'll make sure that my version 1 is out there. The master also contains like the service definitions, so for routing. But as you can see there, this is a cluster that has 4 nodes and a master. Each node is running a certain number of pods, and each pod has a couple of containers in it. So this is essentially like a visualization of what a Kubernetes cluster would look like. Here's an example of a deployment file. You're allowed to use JSON or YAML. They suggest YAML because it's very human readable. If you haven't used YAML, it's essentially like JSON, but instead of brackets, curly braces, you use indentation. So,
by the way, everyone who uses YAML initially hates it, and then it starts to grow on you. I used to absolutely hate it, but now I love it. So,
Python fans rejoice. But it contains the declared desired state. So this would be a deployment file for Nginx. If you want 3 copies of Nginx 1.7.9 running on port 80 within your cluster, this is how you would do it. Within the YAML files, you can declare essentially any type of resource. It could be a deployment, it could be a pod, it could be a service, replication controller. You can create any of those within a YAML file and ask Kubernetes to create and maintain it for you. Kubernetes also does some cool things like automatic rebooting of pods if something crashes. It'll do things like rolling updates, where if I have version 1 out and I ask it to push out version 2, it will add it'll add version 2s, but it'll make sure to take down version 1s only when version 2 is available, so that there's no downtime. Even if I'm just running one copy, I can.
So just to add here, AJ, yes, I will be sharing notes. Those will be in the description section of this video and of the previous one, which is the part 1. What was I going to say? I was going to say, the mechanics of dealing with deployments typically when you're not using some kind of out-of-the-box solution is just an absolute nightmare. Like some of the things that he's describing right now, like making sure that you take down your machines that are serving your application, you take them down slowly, and then you just start swapping them out with a new new software rather, and then making sure they come up in a healthy state. The mechanics of that are very complicated, so this solution kind of handles that for you, or at least Kubernetes seems to.
Have version 1 running on one copy, it'll boot up version 2, and as soon as version 2 is ready, it'll take down version 1 and change the service to point to version 2, so that from the client perspective, there's no downtime. They won't even necessarily know that change happened, but it just does on the fly. And Kubernetes handles all of that for you. So it's so cool. So I'm hoping to show you guys some of this. All right. So let's break it down. First thing we're going to do is talk a little bit about Docker. I'm going to pull up a terminal here.
Give it to me.
Let's increase the font size.
Come on, James. Kill me, buddy.
All right. So if you have Docker installed on your machine, you can see I do. You can see all of your current running pods by doing Docker PS. So right now I was messing with some stuff earlier, prepping for my presentation. So I have some running right now, but I'm going to kill those off so that we can start fresh. All right, now if I run sudo docker ps, I don't have any containers running. There's nothing going. The most basic thing you can do is docker run. So this is going to...
I think this guy screwed up. You can't see what he's typing.
Run a container. So now I have to tell it what container I would like to run. And I would like to run hello world. I think there's no dash here. This is just going to run Docker's hello world application. Just kidding, there is a dash. So here's the Docker basic hello world. It just shows you, all it does is just print this out. So we'd like to do something a little bit more complex than this. So there's a container called also hello world, but by Tutum, I think, tutm/hello-world. And it's another hello world file, but it actually runs a web server on port 80, and when you hit it, it's going to show you a web page, and it's going to show you the container ID of the container that this application is running inside of. So this is cool because it lets you see as you spin it up what container it's running inside of. So we're going to run this. -p is for port. So we're going to bind a port on my machine to a port within the Docker application. So I'm going to say port 3000 on my machine is going to map to port 80 inside this container. So if I hit localhost 3000, it's actually going to route that to port 80 inside this specific container. So that's running now. there's nothing happening, but it's running. So let's come here and go to localhost 3000. We get our hello world, and this is the ID of the container that is running. Just like that. So if we come back here, oh, you can't see the bottom in this presentation. Hold on. There we go.
Thank you.
That's better.
Killing me, James.
Sorry about that. So you can now see it, and it's running in the foreground. So if I kill that now, and I refresh, there's nothing there. So we can run in detached mode with the -d flag. That's going to run it detached, essentially, in the background. That's my long form container.
All right, I'm going to skip ahead here. This guy's killing me. This is mostly review for what we did yesterday. I want to get to like the Kubernetes part. So he's killing stuff. Oh, do I need to install something? I hope not. Yikes. Probably. Okay, so how do we do this? Kubernetes installation. Getting started. More getting started guides. Different ways to set up and run. Okay. Where's the installation? Oops. Download. There we go. You must use kubectl version. Okay. Linux. Mac. Come on, give me the Windows, man. There we go. We gotta do some path stuff, and then I gotta restart my machine. So this is gonna be a huge pain. Maybe what we'll do, at least in this video, is just watch what this guy has and just follow along with him, and then I'll kind of do it on my own afterwards, unfortunately. I didn't realize I needed some setup stuff here. So let's see what this guy's talking about and what he does, and then we'll just take notes, and I may put something together afterwards with me actually setting it up.
You can set up kubectl to point to anyone at any one time, and then when you're interacting with it, you're going to be interacting with the cluster that you point it to. It can take a while because it actually boots up. Minikube does run inside a VM. Docker, not a VM, but this is running a Kubernetes cluster inside a VM, so it's a little bit confusing, but it takes a minute to start up. But what we're going to be doing is writing a deployment file that is going to contain our desired state for our application. So I have one pre-written here because they're a little bit long. It should be in the description of this video. But our deployment is going to contain 2 parts. So let's start with this deployment. We are creating a deployment. The name of the deployment is Hello World. And here's the specification. I want 5 copies of an app named Hello World. It's going to have 1 container. So this is a YAML array, essentially, containers, and then you have like dashes. Have 1 containers. It's also going to be named Hello World, and it's going to run this image, which is the image that we were running before. So it will pull down that image from Docker Hub, and it will run it, and we're going to run it on port 80.
So this is cool. So this is your deployment file that I suppose you feed into Kubernetes. So API version, don't know what that is. Kind deployment. So I suppose these types can be of any kind, and then you just define it here. So the name of this deployment, I suppose, how many copies you want. This is useful for scaling, obviously. And then the app is called Hello World. And then here he's specifying the container, the name of the container, the image that the containers can be based off. And now he's about to do the port mapping from the container instance and probably exposing it to the outside internet or something like that. So let's see what he does.
Inside that container. The second part is a service. We're declaring a service so that we can access this deployment, these pods, from outside of our cluster. So we need to declare a service. It's going to be named Hello World Service. And what should it target? How will it know what pods to look at? And that's where the selector comes in handy. So we're saying this service is going to apply to any pod that has any application that has the name Hello World. Since we declared ours to have the name hello world, then it's going to be able to know that it needs to target them. We're using TCP, and there's a couple of port options here. And I put comments here to make this clear because it was confusing to me at first as well. There's port, target port, and node port. The port is a port to expose that is only accessible from inside the cluster. So let's say I'm running a couple of pods. They want to communicate with this hello world pod. They would be able to do that from inside the cluster at port 8080. From outside the cluster, I would not be able to access this via port 8080.
Hold on. So port 8080 is, okay, so within the cluster itself. So if you have like, hopefully you guys can see this, yeah. So if you have like 3 machines inside this cluster, right, XXX, let's just call this YYY. So they can all talk to each other on port 8080, right, amongst each other. But if someone is coming from outside of the cluster, they need to talk on port 80. Okay.
The node port is a port that is accessible from outside the cluster. This is if I hit my master node port 30,001. Now I will be able to hit the target port, which is the port to forward to the pod. So from inside the cluster, if you hit port 8080, it's going to forward it to a pod with this name, port 80. If from outside the cluster I hit port 30,001, it's going to forward it to a pod with this name, port 80.
Okay, so let's get that down. That's interesting. Oops. Sorry. Got other things going on my screens here. So what did he say? He said, so in the ports section, when you say port, that's the accessible port within the cluster. Target port is the port that a request on 8080 from within the cluster gets forwarded to. It's also the port that like you're hosting your application. And then node port is the port that's accessible outside the cluster, and it gets mapped to port as well. So target port is the important one here. That's what these two things are mapping. These like port and node port are just different accessors, but they both get forwarded to port 80.
It's a little complex, but it starts to make sense when you actually see it in action. And the type is a load balancer. So it's going to load balance between these 5 instances of our Hello World application. So let's get started. Now kubectl is set up and configured. As you can see, it started the VM, it booted everything up, it configured kubectl to use the cluster, all that jazz. So we can say sudo kubectl get pods. There aren't any. We haven't actually done anything yet. Kubectl get deployments. There's not going to be any. We haven't done any yet. Kubernetes offers a really cool thing called the dashboard. It essentially is a GUI application. Sorry, what is this? Maybe I don't need the sudo. Yeah, there we go. So it's a GUI application for interacting with your cluster. If you are command line averse or you just would like a visualization, you can come in here and you can see this. So again, no deployments, no pods right now, but that will soon change. We could create it from in here, but I'd like to show you guys the command line environment just because, I don't know, it's good to be technical with it. So we are going to now use this the deployment YAML that we created. So we're going to go into that file. As you can see, I have my deployment YAML right there. So the command to create a new resource based off of a YAML file is create. -f is the file, the path to the file that you're going to be deploying. If you already have a resource created, all you have to do is change create to apply. So we're going to go ahead and set that up. So since the service was the first thing inside of our YAML file, it created the service first, then it created the deployment. So now if we come back here and we get our pods, you can see that we have 5 copies of our Hello World pod running. They each have a different ID, and they're good to go. We can.
So is he doing all this on local? Is that what's happening here? I don't know if I understood this correctly. That was pretty cool though, if that's the case.
Get our deployments, and we have a single hello world deployment. We want 5 pods. We currently have 5 pods. There are 5 of them up to date and 5 available. So something that's kind of cool is, check this out. If we open the dashboard in the background, we can come back here and look at our, if we can see this here again. So we have same.
Oh, so this is on localhost. I don't know if you guys can tell up here. So it's on his local. So this is local. This is pretty neat that you get all this stuff out of the box.
Things we saw in the command line, hello world, there's 5 pods going. We can see all these pods. So our deployment says that we want specifically 5 copies of this running. So what happens, say, if one of these were to crash or go away? Oh no, now there's only 4 running, but wait, it creates a new one automatically because we were not in line with the declared state. And so Kubernetes is going to add new resources until we fulfill that state. So if I come back here and get our pods, we still have.
So let's just note that down. Kubernetes automatically replaces failed hardware, even if it's a manual action. So Kubernetes among AWS accounts, those are the 2 things you don't want to lose your login or let people find your login to, it seems, because they can just spin up hundreds, if not thousands of instances and just mine Bitcoin, charge your credit card thousands of dollars. So be careful about those.
5 running because the 1 is terminating because I deleted it. We had 4 from before, and now we have a new one that was just created to fulfill that 5th spot because I created it. Or because I deleted this one. So we still have 5. And that's kind of the power of Kubernetes. Like a pod crashes, a pod gets deleted, something happens, a node goes offline, it will automatically scale up and fill, everything, create pods, create resources in order to fulfill your desired state. So let's demonstrate the load balancing. Let's get the IP address of my Kubernetes cluster that is running. And we said we wanted it was port 30,001. And look, we hit it. It's running, that's this specific container ID, which we would see if we listed the pods, and it actually knows that it's running inside Kubernetes now, which is different than what we saw before, and it knows the service that's running. So it shows port 8080 because from inside the cluster, remember, port 8080 is available. This is the IP address of the master node from inside the cluster. We are outside the cluster, so we had to use port 30,001 to hit this cluster. So there we go. But it's supposed to load balance, right? If I refresh enough, it will change, but I believe Kubernetes uses sticky load balancing. So there, you saw it change. There, it's changing again. If I open up some incognito windows, it should also change. But it is load balancing. As you can see, it's changing. It's difficult to demonstrate because it uses sticky load balancing. But you know it's there. You know it's load balancing. Pretty simple. It's running 5 copies of what we needed. We can really easily scale this, which is one of the really cool parts. So you can set it to do it based off of like CPU usage. We're just going to do it manually. So let's say we know every day 9 a.m. everybody gets to work. They're trying to log into our application, whatever our application may be. So from 8 a.m. to 10 a.m. we need more copies of our service in order to handle the load. The rest of the day it's fine, but just like specifically at that time, it's demanding. So instead of 5, we want to double it. We're going to go 10. Now, if we check it out, it says it's updating. We're not in the desired state. If we check out our pods, it's creating containers. Now we have 10 running, or they will be 10 running once they're done creating. So if I keep refreshing here, now we have 10 going. And you can see these were the original 4. Here was the one that was created because I deleted one, and now here are 5 new ones. And they're all created and running dynamically. You can also scale down. Maybe now it's after 10 a.m. We don't need all these copies. We really only need like 3. Boom, scale down. We can come check it out. It's going to terminate pods up until there's only 3 running. It's going to slowly remove these up until there's only 3. And you'll.
So is this thing free? Like Kubernetes? Like, is Kubernetes free? Like, how do they make money? How much does it cost? Oh, okay. So you can host it anywhere you want. I see. So they do the management for you, but you obviously need to pay them being Kubernetes, and then they're hosting it on AWS or GCP. Wow, it's quite a bit cheaper than GCP. Sorry, GCP is quite a bit cheaper than AWS. I'm surprised. I don't know if this is outdated or what. Pricing. Oh, okay, so this is the Google Cloud page. So that's not really exactly what I want. K8S. Interesting. Stalker going away. Okay. Let's keep on going.
See, it's keeping 3 alive while it terminates all the rest of them. So that's kind of the power of Kubernetes. It's really awesome. So we were using an example application, but what if we want to run our own actual application that we write and deploy it on Kubernetes? We can do that. I'm going to use kind of this example from Node.js of how to containerize and create a Node web application. This is what I'm basing everything off of. So.
Damn, okay. I really want to do that. So let me see if I can figure out how to get this thing installed without having to restart my computer and screwing up this stream. So let's see here. Where am I? What is this thing? Run the installation commands, make sure to specify a download location. What the hell is PS Gallery? No, I don't want to do that. That seems crazy. Okay, let me just try to curl this. Oh boy. Let's get that. Run. What did that do? Find out the latest stable version, for example, blah, blah. Add the binary to your... Oh, I got to do all this. I really don't want to do that. Test to ensure the version of kubectl is downloaded. kubectl. Oh, wait. Docker Desktop for Windows adds its own... Oh, okay. It adds... Do I already have this? Am I an idiot? No. Oh, I do. I'm a fool. Look at this, guys. Boom. All right. No BS. So we can follow along with this guy, I think. What was the other thing he was running? He was running some other command. Minikube. Oh. Do I need it? No, this isn't going to work. Maybe. Hey, Leon. Google originally created Kubernetes. Oh, I didn't know that. If I remember correctly, not sure if that has a factor. Huh. It's good to know, though. Okay, let's see what he's doing now.
In my file here, we are going to use Express, which is a Node package for a web application. So we need to create a new directory here. We're going.
Okay, let me get my thing over here. Let me find, what path am I in? Give me a second, guys. I'm just on my second monitor getting everything set up. Desktop, YouTube. Okay, then what is he doing? Okay. All right. So let's see what he's doing here. So he's doing npm init, so that's what we're going to do as well. Spamming mixspam. Yes. So if I set this up, this should pop up over here. Oops. And I didn't. Untitled. Oh, I think I'm on Linux here. Oh, okay, there we go. Now npm inits. Yes. Okay. So now we should have something here. There's our package JSON. Good. Okay.
Going to initialize all of our stuff here.
By the way, I'm a Node.js noob as well. I never really used Node.js. But I
And
want to learn.
now we need to install Express and save it because
Yes,
we're going to
sir.
be using it.
Wait, what did you do?
And now we need to install Express and save it because we're going to be using it. So we'll see that essentially our package JSON is going to look very, very similar to this. If I open this up in VS Code here, the only difference is our test script here is auto-generated, but we have our main and our dependencies is the big one. VS Code dependencies, we're using Express. So we're going to change this to start, and it's just going to be node index.js.
All right. What did you do? Scripts start. What is it? Node index.js. But we don't have an index.js. I guess we're going to create one. Oh, Minikube is just the GUI. Okay, that makes sense. But it was cool though. It looked sweet. I'm going to download that later actually because it looked awesome. Wait, I want to put that under my to-do. Okay, this is no longer necessary. Oh, you guys can't see this. What is it called? Install Minikube GUI. Okay. Now what?
Which we now need to create. So let's come into our example app. Let's touch index.js. And I'm just going to copy what they have here.
Whoa. You guys hear that? I think it's his audio. It's not mine.
We could write it manually if we...
Whoa. Do I sound screwed up right now? I don't think I do. It's weird. I think it's him. Anyways, in the meantime, hold on. Let me skip ahead here and see if he fixes this because that's super annoying.
And it was based off of Jet.
He does. Okay, so it is him. So let's back up.
Our main and our dependencies is the big one. VS Code dependencies, we're using Express. So we're going to change this to start.
Okay, we saw that.
And it's just going to be node index.js, which we now need to create. So let's come into our example app. Let's touch index.js. And I'm just going to copy what they have here.
Okay, we're going to have to deal with
We could write it manually if we needed to or wanted to, but in the effort of saving time, I'm just going to copy what they have here to send. It's just going to send hello world on the host and port declared up here. You can do these using environment variables if you wanted.
Oh, God. Maybe he gives the link to it. Maybe. Oh. Yeah, I have a little bit of echo just because I'm in a room that's high ceilings and stuff. It's not ideal. Oh yeah, so this is what this guy had. Okay. I'm going to save this link too if you guys want to follow this later. I'll put that in the notes, links, and I'll also grab this YouTube video too. Okay. And did he change anything? I don't think he changed anything.
And I'm just going to copy what they have here on the host and port declared up here. You can do these using environment variables if you want.
Let me just check. So Express, port 8080, local, starting Express, sending hello world, last hi. And then we're Just logging that we're running. Okay.
That's how a lot of stuff is done within Docker and Kubernetes, because you don't want to hard code some of this stuff. You do it using
Hallelujah, he fixed it.
environment variables. So you declare database connections, hosts, ports, all that kind of stuff using either a configuration service or using environment variables. So that's what we're going to use. But now we need to containerize this. So how do we do that? We need to create a Docker file. I have one pre-written here, so I'm just going to copy the contents and explain.
Let's do that. Oh wait, he gave that too, I think. This guy's the man. Go away. And then you just paste that in here. It's just called Docker file. Docker file, and it's at the same level. Oh, there it is. Okay, so it's on the same level. So let's just call this that, right? And then paste. So it looks like I have a couple things. My main language is Java. I've been programming Java for the past 6 years in a professional environment. I used to be into front end back in 14. This was when Backbone.js was new. And Knockout.js was the other one that a lot of people used. Angular was just coming out. It was like Angular 1.2 or something like that. And people were like, MVC, that's sweet. But yeah, so now I'm trying to get back into it because I want to see what the outside world uses.
Explain everything to you guys. So inside here, we need to now...
Did he put the same thing? Just want to back that up a second.
Node Carbon, that's node 8.9, but we can go look. So we can go to the Docker Hub.
Oh, I went too far. Because I have like an extra thing. Oh, package lock JSON. I think that was it.
The only thing that's database connections, hosts, ports, all that kind of stuff using either a configuration service or using environment variables. So that's what we're going to use. But now we need to containerize this. So how do we do that? We need to create a Docker file. All right, so let's...
Okay, so the only thing he has different is... I just have my package JSON lock. I'm just going to get rid of that. Copy expose port 80, and then we're running start. And I think we defined start in our package JSON. Oh, there it is, start. So it's going to run index.js, and index.js, we're just starting up our server. So that looks pretty sane to me. That's cool.
Let's go over this line by line.
Yes, please.
First, from. From is always the first command inside of a Docker file. And the remainder of the line is another Docker image that our application is going to be based off of. So in this case, we're using Node Carbon. That's node 8.9. But we can go look. So we can go to the Docker Hub. And you can search for pretty much any image you want. There's Node here. You can see these are all of the supported tags. We could use 9.0. We could go all the way back to 4.8.5 if we really wanted to. But one of the kind of cool things is you can see Docker files, since my application is going to be based on Node. Node has to be based on something, right? So let's check it out. In here, we can look at the Docker file for Node, and you'll see that the first line in here is from build pack dependencies Jesse.
So this is the, he's just talking about the descendancy, but I think he's going to continue on that.
Which contains a lot of just libraries and dependencies, which then Node uses to build off of that, and then we're building off of Node. So it creates this layer of Docker images that everything is built up off of. One of the really cool parts of this is that then when I'm building my image, and you'll see it when we actually end up doing this, it's going to show those, you'll see that there's going to be like, I think 6 or 7 layers to mine. But in the future, if I were to rebuild the layers, it actually is going to I think it hashes those layers to determine if they've changed. And if not, it won't actually even update the previous layers. It essentially creates this caching based off of hashes to determine if a layer has changed, and then it can just plug in a layer instead of having to rebuild the entire thing. So the first time I build it, it'll probably have to do everything. But in the future, if I rebuild it, it won't have to build up the Debian and the build pack dependencies and the node. It'll just plug in the existing copies of those layers and then just rebuild my image, assuming that I change it. All right, so from Node Carbon. Inside our container, what is our working directory going to be? We really could declare pretty much anything, but it's common to put it inside user, your user directory, because you're not going to be interfering with anything else inside the container.
Just seeing your chat going on here. Yeah, I'm good at Java. Switching frameworks. Yeah, the thing with, so the reason I never liked JavaScript is because it's so unstable. It's like there's always these constantly moving things and new frameworks coming out. Like at the time there was Ember, there was, what else? Angular came out, Nocco, Backbone. It's like I don't have the mental capacity to really learn one of these things, thicken through, and then a few months later, the flavor of the month is something else. It's just like, I don't have time for that, you know? So when I want to learn something, I usually like to learn something that's well established and just generally accepted. And that's the problem with the JavaScript community. But that's not a problem in the Java community. It's like there's Java 8, which is like the de facto standard that most organizations use now. And they're slowly upgrading, moving on to Java 10. But it's very, very, very stable, as opposed to what you see in the front end full stack world, where it's just like everyone doing everything, whatever works, right? And then you also have the problem where it's like you have Python developers that want to write backends, so they use like Flask and all that, right? There's no like one centralized language, and I feel like Node.js is probably the closest to the standard. At least a lot of the like friends that I talk to that start like pet projects. I was getting into Python a lot, but I think Node is probably a better choice. I basically want to be in a state where I can easily stand up like any scalable system. Like if I have an idea for something and I want to build it, just like bang, know exactly what to do, spit everything out. That's my end goal. So I'm thinking like Docker for that, Node.js, plus like Mongo or something like that. Oh, there's a Java 14. There's like a million versions. Whether or not people migrate to the new version is a different question. That's usually very difficult to do, especially when you're in a big company that has lots of like moving parts, lots of microservices. It's hard to upgrade sometimes. Oh, don't tell me Node.js is going to get replaced, please.
We need to copy over our package JSON. And one thing that I need to do, I didn't look, what version of Node am I running?
Oh,
okay,
no.
it's just npm.
What version am I running? What's the... Okay. 12.18. Is that good?
All right, so I'm on an old version, so I don't actually have the package lock. But let's update.
This guy's on 3. How old is this video? It's not that old.
Just for the heck of it, because we're using 8.9 here, so we should probably be using it. So npm version 5 and above introduces a new concept called the package lock. I actually wrote a blog post on Medium about it. You should find that and read it if you're interested in what package lock is and what it does and why it's important. But so to demonstrate it, we're going to use that. So we're going to need to run npm install again.
I suspect package lock is like locking in versions of a dependency, like taking a snapshot with a particular set of dependencies and a particular set of versions, so that your app doesn't blow up if you kind of, if some update of your dependency happens, you don't have to like you're not getting that new dependency without explicitly declaring that you want it. Probably something like that. Let's just look it up real quick. Package lock. Package B. Can I just have a one-liner, please? I don't want to read all this. There we go. Package lock is automatically generated for any operations where npm modifies either the node modules tree, exact tree that was generated such that subsequent installs are able to generate identical trees. Right. So if any dependencies change, if you use the same file as the source, you'll get an exact copy. Even if the dependencies change in between the time when you wrote it and the time that you're running it. Cool.
And it'll generate the package lock for us. So we need to copy the package JSON, but we also need to copy the package lock JSON.
Oh, right.
And that is important if you are using NPM version 5 and above. You should be copying your package lock as well as your package JSON. Now run a command. What are we going to run? npm install. So now inside of our container, inside of the working directory, we're going to install all of the packages that we need to run our application, which are declared in our package and package lock. Then we need to copy the remainder of the files, expose a port, 8080 in this case, and then the command, this is when I run my image, after I've built my image, when I actually say docker run, my image, what is it going to do? And the answer is it's going to run npm start, because npm start just runs node our file, and then it will create our server. So you might say, well, why would I want to copy the entire source into over there? Like, what about the node modules or any debugging stuff? I don't need that in there. That's just going to make my image bigger. And that is where you are correct. So we're going to create a docker ignore, very similar to a git ignore file. And we're going to ignore the node modules so that when it copies...
Hold on. That seems like it's something important to do. Docker ignore, right? Text. For the Kubernetes GUI, I think you can use Docker Desktop. That would be cool. Hold on. I think I have it, right? Dashboard. Oh, there's Kubernetes right there. Context. No context available. It's probably because I have nothing running right now. What's this? What's this? Oh, sick. Deploy Docker stacks to Kubernetes. Yes. Show system containers. This. Yes. Okay, hold on. Apply. Okay, I'm going to let that figure itself out and continue here.
Everything. It's not going to copy the node modules because those are going to be installed here. And if we had other things that were important maybe for developing, but not for the production application, you could also put those in your Docker ignore, and then we wouldn't, they wouldn't be copied over into your container when it gets built. So that's all you need for a Docker file. You need your from, you need to establish your working directory, do any commands that you need. That's essentially the section. Any commands that you need to build your application, copy your files into the container, expose the port that you want it to expose if you need it, and then a base command that will be run. This is an array because the first argument is the actual name of the thing, and all subsequent arguments or elements in the array are arguments that would be passed. So if I wanted to pass extra flags or anything, I could just add elements to this array and it would do it. So now we need to build this Docker file to then run it. So we can say docker build -t is going to be our target. What are we where are we targeting? Or sorry, -t is the name of the Docker file that we're building. So I'm going to use my Docker account. This is going to be
I don't have an
example
do I have a Docker account
version.
I don't think I do. Do I have to have one? Just put something else in here.
1.0.0. We're going to build it, and then the last argument is the path to the Docker file. Since it's in my current directory, I'm just going to put dot, and that should be able to go.
This is going to fail.
So you'll see, here we go, our steps, our layers. Let me pull this up here a little bit. So, our first layer is going to be like the scratch layer from base. Then you're going to have the
My stream is probably going to explode right now because my internet's getting like destroyed downloading all this. It's almost 3 a.m. I have to watch the video later on. Take care, Ignore My Chan. Thanks for stopping by. I appreciate you coming by and commenting and everything. Yeah, I'll put this video up. Well, I think it posts automatically afterwards. So if you want to watch the rest, you can see if I succeeded or failed here. I'm just going to let this run. Let's go, man.
In Jesse, then you're going to have the build dependencies curl, build dependencies SCM, build dependencies Jesse, then you're going to have node, then you're going to have my application, and evidently there's one more in there that I missed, but essentially that's that's what it's doing. It's downloading each layer and it's building them up and it's compiling them into the image that can then be run on any machine that also has Docker.
Cool.
So the first time, as I said, it's going to do this all, and it's going to take a little bit. But if I were to make a change and rebuild, it would actually take significantly less time because it would only have to do the layers that changed.
Let's test that theory. I'm going to change something. Now, let's do it again. Huh, okay. So it didn't even, well, it obviously would have built that really fast. But it seems like it went super quick, but that's cool. All right. I'll take it.
Which would be my code, not, all these previous libraries that already exist. So now it's running our Docker file. So that was just downloading the previous layers. Now it's actually running. So you can see it established our work directory. It copied over our files. Now we're running npm install. We copied over the rest. We exposed the port, and we set the command. Now it's built. So if I want to run this, we're going to run, we can port 8080 to 8080, again, mapping our local host port 8080 to port 8080 inside the container. And we're going to run example app. I don't know if this will still be up on my Docker hub when...
Okay, so let's try this. So Docker run -p 8080 on my machine to 8080 on the Docker container. What did I call it? It was just like foo, right? And I think it's foo : latest. I think it appended that automatically. Oh, is it working? Oh. Foo, 8080. Okay, hold on.
You, viewer, are doing this. You can try to use mine if you want. Just substitute my name for your Docker account, and it should just work just fine. So if we run this, we see it's running our container. If we now go to localhost 8080, we get hello world.
Big money, big money, big money. Oh no. Local hot. Hey, we did it. Go team. All right. So we're halfway there. So what did we do so far? Let's recap. So what did we do? We initialized a Node.js module or Node.js package. We screwed with the starting script here. We just added an index.js as the start command. And then I created a Docker file with all this business, and I specified the command to run on startup to be npm start. It's going to happen on port 8080, and all this other business. So from is specifying that we're on the Node.js parent. And then we have index.js, which just launches basically our Express server. And then we're just logging out everything here. But this is working. This is pretty cool. So let's go to our container now. I want to see the logs. I think you can see the logs from in here somehow if I remember how to get back. Cancel. No containers running. That can't be true. Aren't I? Thought I was. Maybe this just needs a good old reboot. Yes. Okay, so that killed. If that doesn't work, I'll just do like Docker PS. Okay, so this is starting up. Let's continue the video, then I'll try it after.
Which is exactly what we expected because it's what we declared in our index when you hit just, this, print hello world, and we saw that it logged this running on the host and port. So we've built up a Node application. Obviously, yours is going to be more complex, different than this, but the steps remain the same. We wrote our Docker file. We now have built our application. So let's run it on Kubernetes, yeah? So all we have to do really is just change our deployment YAML here a little bit. I'm going to kill that application. And now let's switch this up. So this is our own Hello World service, but I'm going to change this to example service because we already have the Hello World. We're going to be targeting any pods that have my app as the thing. We want to target port 8080 because we are using 8080 in here and in our Docker file, port 8080. We're going to switch these up because we were already using these for the Hello World service. So we're going to say 8081 and 30002 because we can't duplicate ports. And here we go. So let's switch this up. So this is going to be my app. Let's run 5 copies of it. Let's name this something different. Let's actually call this my app deployment because this is the name for the deployment itself. And this is the name for the selector for the pod. The container name is, we'll call it my app. And again, as we said, we're going to run James Quigley example app and container port 8080. Now, if I did everything correctly, this should just work. So let's try it. Sudo kubectl create. Actually, I need to go back into the main directory. Sudo kubectl create deployment YAML. Helps if I spell create correctly. All right, it's going to create our service. It's going to create our deployment. Let's check out our dashboard. We can now see
something's wrong.
Oh, that's why. Important step. We created the image and we built the image here, but we did it locally. So it's stored on my local machine, that image, but I never actually pushed it. So I can quickly, let's see, we got to push James Quigley / example app v1.0.0. So now it's going to actually push this up to Docker Hub. So if we go onto my Docker, we'll be able to see a list of my repositories, and you can see a few seconds ago I just pushed example app, and the only tag is going to be v1.0.0. So now it's available publicly. So let's come back and try to redeploy our thing. Let's do apply here, and I'm actually going to specify the exact selector that we want here. If you don't specify the tag, it's just going to pull the latest. So we're just going to tell it this one specifically. Yeah, that's totally like optional based off of what you.
So you got it running.
I'm going to delete these just to like make sure that they get cleared out. It shouldn't be a problem. Kubernetes should handle it, but it seems like it thinks.
Interesting. So I need to go register with like an account and everything.
If we hit
on my Docker Hub so that I can do all this. So, but this has been pretty insightful. So let's just go over what we've learned. I'm not going to watch the rest of this. I think he's just going to kind of overview the GUI, which I've already seen. So what have we learned so far? So we learned a little bit about Kubernetes. You take a declared state in your deployment file, and it works to make that happen across the cluster. You have a node, which is also known as a kubelet, and it runs pods that talk to the master. The node is a machine. A pod is a thing that runs a container, one or more. So they have like a concept of load balancing that's handled automatically for you. Deployments, you specify what you want to do in the deployment, and it kind of makes it happen for you. Also does the, take a group of hosts down, put up another group of hosts, et cetera, with the new software. And that's seemed like the responsibility of the replication controller. And then what else do we have? The deployments specify the specification. Then we have a port section, which maps out what the exposed ports are, what the inter-pod routing will look like, and the port mappings between inter-pod communication and intra-pod communication. So this was with regard to an example, but target port is the thing that seems to matter the most in the build file. I think it's the build file. Could be a different file. Replica specify the number of instances that you want, and then it automatically replaces failed hardware. So I have some things that I need to do for next time because I want to get this working with Kubernetes. So I'm going to install a Minikube. I'm going to register for a Docker Hub account as well so that I can go through this end to end. But I think I'm going to call this a show right now. So I've been going for about an hour, so that's pretty good. Appreciate everyone coming out and chatting and everything. And this will be available afterwards for playback on my channel. So if you want to take a look then, or if you missed something and you want to watch it in slow-mo or something. So thanks very much, everyone. I will stick around for another minute or two, and then I'm going to close it up. But thanks for stopping by. Mm-hmm. Nice. Thirsty Jones. Mm. Do. What do you want? Oh, you need a hypervisor for this? Oh man, okay, I'm not doing this. Man, I gotta get a Linux box. Okay, thanks everyone. I'll catch y'all later. Thanks for coming by again. Have a good night.